experiment, I want to all of the information are same, but only I changed it to from 120 to 200. So I want to experiment it twice and take the average of it. The first one is 63. 63. And the second one, it's 62. And what I counted was 79. So it was only with 300 error. So it's my experiment.
Okay, today I want to experiment the Newton's second law, find the mass acceleration. First of all, this mass is 250 grams and this mass is 120, it is to 140, 160, 180 and 200. First of all, this mass has to hit this root, so I find the displacement of that. 50 centimeter is approximately like here. So the D is 50 centimeter or 0.0 meter. This one 250, this one 120, and we want to find the time that it hits this spot. So 1.20 again. It's 1.21, I have to show that I guess. And I wrote 1.23, so it has error by 200. And I will change 120 to 200, so I guess I have to pass the video right now.
So that was Ali Majidi, who is me, doing the Newton's second law experiment. We used pulley, strings, and the objects that's hanging over the pulley, and one of them over the table. The object over the table was 250 grams and stable, and we changed 120, 140, 160, 180 and 200 grams, which was the mass hanging over the pulley. So it was the setup that I made myself. I don't mean that the stuff was mine. We had a setup that was used by another student, so I had to use tube and paper and something like that to make a manual setup. And we find that for heavy things we need more acceleration, and so it was obvious that our data may have some errors, and we find that it was about 1%, 2%, 3% and 4%, which are really low error percentage. So it ended up that shows the Newton's rule is spot on. At the end of this video, I will add my data, error graphs, and this is my experimental setup, which shows here, and this is my data and my graph. These are error calculations, and the percent of error is 420, 140, 160, 180 and 200 grams, which are 2.64, 5.22, 4.20, 3.81 and 1.56.